Hello, everyone. It's a pleasure for me to be here, to be part of the first technical session of SVR 2021. And these sections, we have 4 papers about augmented reality. And I think it is quite interesting. And I'd like to invite all participants and attendees to share your questions in the YouTube channel, in our SVR YouTube channel, and also share your questions in our Discord channel. Okay, don't wait to finish the session to put your questions. You can share your questions anytime. Okay. And so the first work, we can start. The slide from the first work is development and evaluation of a PCB's manual assembly system using augmented reality and total quality. And the presenting author is Salvador Sergi Agatti. So you can move it for the video, please.
Hello, my name is Salvador Sergio Agatti, and today I'm going to present you the paper entitled Development and Evaluation of a PCB's Manual Assembly System Using Augmented Reality and Total Quality. Following, you have a summary of what we will talk about. Then we present the run system architecture and talk about the AR and PR modules. Then we present the questionnaire sent to the experts, and finally, we do the discussion and make the paper's conclusion. Despite the advances in industry, manual assembly is still a presence in manufacturing due to human capacity to support the changes in manufacture variations. But with new improvements in production lines, with a higher precision, reliability and stability of the automated production, human error became more clearly the enemy of product quality. An alternative to pursue the quality industry 4.0, mainly in the manual assembly lines, is using augmented reality. The figure you are seeing is the round system architecture. Number 1 shows the webcam used to grab the image of the printed circuit board the operator is mounting. Its position is, in fact, above the operator's head and doesn't interfere in the workspace. The webcam image is then sent to 2 models, the Vuforia Augmented Reality module and the OpenCV Pattern Recognition module, as indicated by numbers 2 and 3 in the figure. Number 4 shows the storage module, which records and presents image markers, 3D models, assembly instructions, and production KPIs. Number 5 is the user interface, which combines the output of the AR and PR models and presents the result in the output module, which is, in this application, the monitor the operator already has in his working environment. You are seeing the monitor's output. Number 1 is a tag showing in which step the assembly process the operator is at the moment. Below this information, the operator has detailed instructions on how to mount the component of the PCB, as number 2 shows in the image. Number 3 shows the component name, code or number that must be picked up from the respective bin. Number 4 is a 3D animation of the component being mounted at the moment that rotates in 2 axes, allowing the operator to see all its features like color, polarity, and important markers. Finally, number 5 shows the position indicator arrow that helps the operator on where to place the components in the PCB. The PR model is responsible for validating the PCB assembly. Its function is to validate the step, which a set of components mounted comparing a previously validated image with the current one. As you can see in the image, the PCB must fit into a predefined rectangle area to allow the PR model to work properly. RAN system evaluation was carried out through an online questionnaire sent to specialist professionals. The questionnaire measured the perception the evaluators had about the developed architecture and the features RAN has. The final questionnaire consisted of 14 questions divided into objective and subjective questions. The system and its functionalities obtained positive evaluations both by technology professionals and by the assembly professionals. The group of assembly professionals was the one who gave the best scores in numerical evaluations to RAN. The best evaluated aspects of the system were the graphical indication of the components, the distinction of the components, and the component position on the PCB. In the subjective question about positive issues in advantage, the factor that stood out the most was the use for training. The following best commented two factors are directly related to the requirement proposed for this work: the tasks, errors, and in general results, quality. The responses received in the objective questions pointed out the difficulty in recognizing the assembly errors as the main limitation of RAN. The final overall score of the RAN evaluation was 80.15 on a scale from 0 to 10, and therefore it can be said that the system was rated as very good. The responses obtained found that RAN has potential benefits. For example, the RAN system stands out positively both in the operational aspects raised in the system requirements and in its training potential, which was not an initial objective. The answers raised questions about the system's interface, indicated the addition of features to the architecture, and suggested different ways of applying the system, such as hardware configuration and quality improvement features. The system is ready for initial implementation on the assembly line. Thus, the proposed solution is considered a useful tool to make the PCB assembly process more efficient according to the expectations of the professionals involved. The system is expected to be implemented in the real industrial setup and bring benefits such as error reduction, improvement in product quality, improved control of the assembly line, and help in the assembly process for beginners. Future work includes making the system adaptable to user experience as well as gamifying the experience to sustain high productivity for a longer period. Thank you.
Thank you, Salvador, for the presentation. And now we have time for a couple of questions. And okay, Joma has a question. It was nice to see how this work evolved since the last 2 years. What are the next steps now? Do you already have plans to apply it in the real industry?
Right. Thank you very much for the question. I thanks Joma for reminding us that last year we presented the proposal for this system. It has been implemented and tested in a bench, in a workbench, not in a real setup. So the next step is actually adjusting the system according to the real setup in an industry nearby Joinville in Santa Catarina. And we already identified some needs regarding the use of the system during a actual task. For instance, the people from the industry have some internal standards, I would say, like a capacitor, which has some marks like positive and negative. We usually mark the positive, but they asked us for the negative one side to be identified. And this is ongoing process. We actually doing this right now in installing this system at the industry, and we will perform some extra evaluations afterwards. In terms of the project, this first part was the Ruggieri's master's degree project, and Salvador is doing a doctorate degree, completing this project with gamification. So we intend to not only applying the system at the real setup, but looking for assurance that the advantages, the benefits, would stay for a longer period of time. We have from the literature very good expectations regarding improvements once we install the augmented reality system. But the literature also says that after a while you can see some decrease in the performance. So we intend to use gamification, and that's the main project of Salvador. And with the gamification, we will try to sustain the performance for a longer period of time. So this is one of the main developments from the previous work. Another development is regarding training. The industry perceived a very interesting opportunity in terms of training their people. We did not intend to go to this path, but they were very assertive. They wanted the system to be part of a training system, a bigger training system, their bigger training system. And we now considering this approach and this opportunity. And the third one is regarding quality management. We're going to integrate pattern recognition at the end of the assembly line. So we intend to verify if the assembly is correct, it's done with all details in the correct manner, although some of the components can be mounted as sideways or upside down. It depends on the printed circuit board. So this is the three main developments that we planned for this research project. I hope I have answered Joma, and I get back to Daniela.
Great, great, Marcel. Thank you. We have another question from Marcio Pinho. Thanks for the presentation. In which aspect do you think the tool can provide more advantages in time for the task or quality of the final assembly?
Right. Hello.
Oh, yes.
As long as we could see at this moment, they're both improvements that we expect, both in terms of time, in time of the time to complete the task, but also quality. Quality is a main aspect in the industry. And when we study quality, we see that quality is regarding control. People from the industry want to control the time for each task, for each assembly, not the whole printed circuit board, but for each component. And they want some steady rhythm of assembly. They don't want one part of the assembly to be done in a very fast way and the next one in a slower way. So they want to get the rhythm balanced between various steps. And this is the kind of control quality looks for. So at the end, if the rhythm is correct, if the tasks are correct, then you can assure quality according to quality total management definition. So we're expecting time, we're expecting quality, and we're expecting to give a lighter workload to the operator, because the augmented reality will tell step by step what to do. So the operator would not have to remember what to do. He will follow specifically instructed points. Okay, so there's another opportunity for improvements as well.
Great. Thank you very much, Marcelo and Salvador Agati. And I'd like to remember all participants and attendees that this discussion can be continued further in the Discord channel. Okay, let's move on to the next work of this section. It's towards transparent markers, and the presenting author is Arthur de Andrade Almeida. Let's go.
Everyone, welcome to my presentation. Let me start by saying a few words about motivation. Currently, researchers perceive a shift in the use of market-based solutions to markerless techniques. Market-based AR, despite being still used in some scenarios, had its importance in the early years of the field. Nowadays, it is still possible to find some applications, such as the ones applied on web browsers. Market-based AR makes use of fiducial markers that are used in the real environment to help the tracking process. AR markers, also known as fiducial markers, are objects inserted in the real environment and captured by the camera for use as a point of reference or a measure. Now, we will discuss some of them briefly. AR Toolkit was originally developed to work with a head-mounted display, displaying live videos from conference calls, and a virtual shared whiteboard in the market surface that allows both a light pen and a mouse to be used to interact with it. AR Tag was based on AR Toolkit and was created to deal with the false negative mark detection problem. AR Yuko uses a combination of multiple markers with an occlusion mask to create a fiducial mark for camera pose estimation. Transparent markers bring new application scenarios that were not possible to implement with conventional markers. Some characteristics that most AR markers have in common are high contrast, which helps the system with detecting the marker in the scene. Besides that, the high contrast property can be achieved by using strong colors or simply black and white patterns. Anti-symmetric pattern, which helps to determine the correct pose relative to the marker. The system needs to tell the difference between its four sides, as conventional markers only consider a single side of the printed marker. The asymmetry, in this case, refers to horizontal and vertical ones. In order to construct transparent markers, some additional requirements are necessary, which are front-back visualization and superposition of markers. While conventional markers simply consider horizontal and vertical asymmetry, in this case, diagonal asymmetry must be considered as well, because of the flip effect. Imagine viewing the marker on a mirror. This is basically the same effect whenever the marker is viewed front-back. As an example, the figure the figure shows 4 by 5 digit patterns that can be used inside the transparent markers. According to the asymmetry requirement, the digits 3, 8, and 0 cannot be used as inner patterns because of their symmetries. On the next slide, we will see a short GIF showing how the markers work with the addition of front-back support. We can see here the front-back capability. When we rotate the marker, the character is rotated, and when we flip the marker, the character's back is shown. Another feature of transparent marker is their capability of being stacked together and keep being recognized up to a certain number of markers. It's important to notice that markers that have zero interference over each other work as orthogonal markers, but this restricts even more the number of possible markers available. For example, the figure illustrates a way of generating such markers. We may select one of the concentric squares for each marker and set some black pixels to make it asymmetric in all combinations. Since each different marker has its pattern on a different radius, there is no combination that leads to the superposition of the inner patterns. This makes it easier for recognize different markers stacked together and also improves the certainty of the detected marker. This GIF illustrates the marker stacking capability. Both markers 4 and 5 are superimposed and are highlighted in green. Note that both markers can be detected separately, as shown in the top right and in the bottom left parts. Now let's provide details about tests and validations. We designed the markers based on simple digits from 0 to 9. Each of them were represented as a 4x5 grid and later extended to 5x5 so that the inner content had a square shape. After placing the inner content digits inside the black border and scaling the markers to a higher resolution, they were printed using an inkjet printer. Since the front-back detection capability is assured in the construction phase by checking if there is any symmetry on the inner content of the markers. To check the marker superposition capability, we perform different combinations of pairs containing 2 of the 7 printed markers available. Given the low resolution of the inner content, there was too much interference among them and only 2 showed no interference at all. Pairs 4 and 5 and 4 and 9, as we can see in the table. Since only 2 different combinations of markers were able to be retrieved without fail, any triple combination of markers would result in less than 100% accuracy. To alleviate this problem, we decided to increase the resolution of the marker's inner content to 10 by 10 and verify the interference this new configuration would cause over the markers. As expected, we had more cases with no interference at all. More than half of the combinations showed a 100% accuracy rate as shown in the table. Digits 1 and 4 showed the worst results related to interference. Every other digit performed better than 1 and 4, since there is no interference among digits 2, 5, 6, 7, and 9. By not using digits 1 and 4, we would be able to stack together up to 5 markers and correctly recognize them. This would allow a higher number of possible applications using the proposed marker style. Thanks everyone.
Thank you, Arthur, for the presentation. Very nice work. And we have a question from Marcelo. QR code has 30% robustness. That means 30% of the image can be occluded. How robust transparent markers can be?
Thanks, Marcelo. It's a very good question. Remembering that the markers need to be aligned, basically we test 2 types of patterns, one that gives some shock and one that doesn't. It's basically that.
Okay, thank you. Another question, could you elaborate a little bit more on the sort of applications that can be foreseen for these transparent markers? Which kind of applications we could use?
Okay, so we have in mind that educational applications will benefit from transparent markers, where someone may stack markers together.
Great, Arthur. And I'd like to mention that I saw in your paper that you have mentioned in the acknowledgements session the name of Professor Claudio Kirner, that which was on the pioneers in augmented reality in Brazil. And also in your paper, we can see very good references on AR toolkits in general. So for the participant that would like to have a very good literature about how to develop and the toolkits that have been used last years, I think it's a very good work. You have done a very good work on that.
Thanks.
Congratulations. Okay, very nice work. And yes, a good overview. Let me see. I think we don't have more questions for now. And thank you very much. Okay, we can move for the next work. Third work of this section is augmented reality on museums, the Ecomuseu Virtual Guide. And the presenting author is Natalia Teixeira. Let's go.
My name is Natalia, and today I'm going to present about an application designed to gamify museum tours using augmented reality. Studies show that smartphones play an important role in improving the experience of visitors to this attraction. Based on this, we developed a prototype virtual guide to enhance the experience of these visitors at a famous attraction in Foz do Iguaçu, the Ecomuseu, which recalls and tells the history of the Taipo hydroelectric plant and the region occupied by its reservoirs. The developed application inserts virtual elements into the museum's trail, and these elements, when captured by the user, inform about what has been exposed in that place, so that the visitor's perception and absorption of knowledge can be improved. 15 different users tested the app. Due to the COVID-19 pandemic, we adapted the app and carried out the evaluation on the virtual tour of the same museum, which is available online. Despite the difficulties imposed by the current context, the feedback from the tested users was very positive. The prototype was developed using basic concepts of augmented reality. With a mobile device and a paper card with an image drawn on it, the computer visualizes and analyzes the figure printed on paper, identifying it and discovering its position and orientation in space. This information allows text and three-dimensional virtual objects to be linked to the position of the paper model. When the card is moving, its position changes in space and the computer repositions the virtual object in the new position, giving users the feeling of manipulating the virtual object with their hands. As a result, AR mobile apps can customize the experience according to the wishes and expectations of a visitor, resulting in a much more memorable experience in an accessible way for both the visitor, as most devices support such technology. The Ecomuseu was designed since the beginning of the construction of the Taipo hydroelectric plant. The museum has several exhibits that tell the pre- and post-history of the Taipo construction through side posts. But during the tour, a sudden fatigue is noticeable when absorbing too much information. The developed application came in the form of a virtual guide with AR resources. The objective is to enable the visitors to explore and absorb everything they see at their own pace, being guided by the application. 6 different capture points spread throughout the museum were implemented and presented to the user in a mission format. Each point contains a specific marker, a 3D model related and adapted to the point, and texts and images also related to the theme in question. As soon as users launch the app, they are given instructions on how to use the app and a list of questions to complete while the museum is explored. Such missions aim to provide relevant information to the visitor in a user-friendly and accessible way, improving their experience in the attraction. It asks the user to locate an object or signpost in the real world. By putting the app's camera at the indicated location, a virtual object is added to the real scene along with the capture button. When the button is pressed, the app opens a panel containing textual and audio information about the location where the visitor is, and a Learn More button that will bring more information about the same spot, with images and a question about the current mission. The user only has access to the information about the point in the app when he unlocks the mission for that point, capturing his mascot. For development, the following tools were used: Unity, IDE used for the app development; EaseER, SDK used for augmented reality; SQLite for internal storage; an external server with PHP scripts and a database server. To test the application, 15 volunteers users installed the app on their smartphones, logged in and executed it as previously instructed, and after they took the virtual tour of the Ecomuseu with the app. It's important to note that the original app was developed thinking that the visitor should have the experience on the spot. Given the current context of home isolation with the COVID-19 pandemic, the application had to be adapted so that all tested users could participate remotely, using the virtual version of the Ecomuseu as a base. After completing the virtual tour, these users answer a questionnaire regarding the experience they had during the test. The table summarizes the characteristics of the 15 volunteers. The feedback questionnaire, answered by all testers after using the app, consisted of 90 questions of the 7 Likert scale points. The applied questions are described on the slide, addressing points such as content absorption, quality of the visitor experience with the app, and about the intention to revisit the museum, with 16% of the volunteers not knowing the Ecomuseu beforehand. The table summarizes the answers given by the 15 testers. As most of the answers given by the users were located in the upper half of the Likert scale used, we can conclude that the proposed AR app provides a positive experience for the visitor when taking the tour with the help of the app. We can also assume, based on intention to revisitation responses, that the proposed AR application actually makes users want to visit the attraction. The execution of the project showed some challenges. The proposed work demanded not only the development of the app, but a previous information gathering from the museum and specific 3D models for the mission. But despite this, it can be concluded that the proposed virtual guide allows explore in different ways a dimension of the tourist experience. So that's it. Thank you so much.
Thank you very much, Natalia, for the presentation. And now for the questions, Marcelo is asking how to balance text information and animations into a museum AR application.
We used a mission format, so the user could only access the text information after capturing the mascot in the indicated place. So the information was not being shown in the same location. Only after the mission is unlocked, are the text displayed to the user.
Okay, I saw. And also, how do you think that you could include sound in the experience, in the sense to improve the presence?
Yes. We included sound in camera, have a player when the mascot was showed to the user. A sound is played in the same time. We have the option. We have also the option to the user play a text after they capture the mascot, reading the text of the information.
Great. And very nice work and ideas. And I think I saw in your results that we have collect data from different volunteers profile regarding the AR previous experience. Did you see any difference in the results regarding these two kinds of profiles, or you don't look for that?
I don't I don't see different results with users don't know AR before and users that know AR before. I can't see difference in the answers.
The answers, yes.
Yeah, just to help Natalia with that, Dani, in the paper, we didn't point out any difference regarding that, but it was perceivable that the wow effect was higher with unexperienced users regarding AR.
Yes, maybe augmented the number of users we can see. It can become more notable. No?
Yeah, actually,
Observe, observe.
the greatest challenge in this project was that the application was constructed by a mobile phone, so it could be run inside the Eco Museum. But with the pandemic, the Eco Museum was closed, so most of the users had to use the simulated version of the museum on the PC, and they were still able to test the application. So that was a very nice alternative to do the project.
Okay, I saw. Okay, good. Also, I remember in the paper it was very well described the user tests evaluation. Just to point out. Okay, thank you,
Thank you.
Natalia. Thank you, João Marcelo, for your comments. And now we can move on for the to the last work of this section. And the work is Rebase, Data Acquisition and Management System for Neuromotor Rehabilitation supported by virtual and augmented reality. And the presenting author is Tiago Trota. Let's go.
Good afternoon. My name is Thiago Trota. Welcome to my presentation on Rebase, Data Acquisition and Management System for Neuromotor Rehabilitation supported by virtual and augmented reality. Well, the loss of motor skills due to neurological damage is a common factor among patients who suffer a stroke. Fortunately, it is possible to recover lost abilities due to neuroplasticity in a process called neuromotor rehabilitation. The neuromotor rehabilitation area can profoundly benefit from applications that use natural user interface devices such as the Kinect and the BSN, because these devices allow the patients to immerse themselves in a variety of scenarios and offer the benefits of traditional methods without becoming boring or tiresome. These applications also generate very important movement data, which can be analyzed either manually by a health professional or through computational methods like machine learning and data mining, which can help extract information vital for the treatment of these patients. However, it is still very difficult to find datasets of body movements, and the existing ones do not include movements specific to the neuromotor rehabilitation context. There is also the need to define and structure the data generated by these applications. And so, we propose Rebase, a framework for creating VR and AR applications for the neuromotor rehabilitation area. In Rebase, the user's movements are stored in a solution specifically designed for this purpose, where only the data regarding their joints is stored. This is much more storage efficient than video files and allows the movements to be reconstructed and replayed from different angles and at different speeds. On top of that, the data is already discretized and normalized for the domain, which allows the application of computational approaches. Also, because it stores the joints as rotations, it allows any kind of body tracking device to be used to generate the data because the movements are not dependent on them. This work was developed in 3 steps executed simultaneously. First, the design of the Rebase database. Second, the design of the Rebase REST server. And third, the design of the Unity Rebase API. The Rebase database was constructed using Apache Cassandra, a NoSQL database that uses tables. It has only one table, the sessions table, with 23 columns. Each line in this table stores a session. These sessions represent either a full rehabilitation session or one single movement made in that session. The art-index pattern column is a very important column. It stores a string that explicitly informs which joints are used in that session. Rebase defines 20 joints, identified by numbers between 1 and 20. The session data column is another very important one. It stores the list of the joints' rotations over time. Each position in this list represents a register. The registers contain the X, Y, and Z rotations of all the joints used in that session at a time instant, like a snapshot or a frame in the video, only much more lightweight. The register list is also compressed before storage. The Rebase REST server is a web server that follows a representational state transfer architecture. It was developed using Node.js and the Cassandra driver and is responsible for the communication between the applications and the Rebase database. The Unity Rebase API was developed in C# to be used in applications made in Unity, with the objective of making it easier to develop rehabilitation applications. All of the classes in the API can be divided into 3 categories: models, which model the data in the database, the utilities, which compress and convert the data, and the REST client, which is the class responsible for sending requisitions to the Rebase REST server. After all that, 3 applications were developed in Unity to demonstrate and validate Rebase's functionalities: the Rebase Session Recorder, Rebase Session Player, and the Rebase Session Manager. The Rebase Session Recorder allows the user to record sessions, edit their metadata, and then insert them into the Rebase database. The Rebase Session Player lets the user access the sessions stored in Rebase, reconstruct them, and play them back. The user can move the camera and change the playback speed, among many other things. And the Rebase Session Manager allows the user to edit or delete the sessions as well as play them back through an integrated instance of the player. In conclusion, this work presents a framework for developing VR and AR neuromotor rehabilitation applications called Rebase. Rebase is made up of a Unity API, a REST web server, and a NoSQL database that stores movements in the form of the rotations of the patient's joints. Rebase allows the use of any kind of body tracking device to record the movements, and from the data stored in it, it will be possible to build data sets of different joint sets and movement types. We have also developed a set of tools designed to support Rebase: the Rebase Session Recorder, the Rebase Session Player, and the Rebase Session Manager. In the future, Rebase will provide a massive volume of movement data so that a variety of data analysis techniques, data mining, and machine learning approaches can be applied to infer relevant information about physical therapy sessions. I'd like to thank everyone very much for watching, and I hope you all enjoy the rest of the event.
Thank you, Thiago, for this nice presentation and very interesting work. And we have some questions. Marcelo is saying that a demanding part of rehab is data analysis. How the framework help presents visualizations such as graphs, curves, and others?
Thank you for your question, Marcelo. Rebase is focused only on defining the storage pattern and providing the API and the interfaces for storing the data. So it does not provide any sort of visualization tool. The visualization part is left entirely up for the applications to implement however they see fit.
Okay, I saw. Is this job is done outside, from the framework. And Thiago, who is the users expected to be for this framework, in the sense of which kind of expertise or acknowledgement the users should have?
Well, Rebase is intended to be used by health professionals that work in the neuromotor rehabilitation area to collect and analyze the movements of their patients. So, but in reality, it can be used by any kind of application using body movements, but the main focus is health professionals.
Great. And another question, and Salvador Agati is asking, how did you recruit the participants? Where to find this type of population? I'm not sure if you have done some experiments, no?
We haven't really done any kind of formal experiments yet, but Rebase is already being sort of tested. This some kind of alpha test at Cepid Brain in Campinas, São Paulo, and being tested by our development team too.
Okay. And also Marcel is asking, can Rebase detect the joint limits being extended, going beyond natural?
Well, Rebase doesn't isn't really concerned with storing only realistic movements, so you can store any kind of movement. It's left. This is another thing that's left for the applications to treat. You can store any kind of body movement in general.
In general, okay, I saw. And can it be used for ergonomics analysis?
And definitely can be used for ergonomics analysis. The main focus, as I said, is neuromotor rehabilitation, but any kind of physiotherapy or any kind of health area that's concerned with body movements and poses, like posture, for example, can definitely benefit from Rebase.
Great. And very interesting, a lot of potential for future developments for sure. Marcelo
Thank you.
comments. Okay.
Thank you very much.
Very nice work. I really enjoy also all the works from this section. And I'd like to remember that this discussion and the PDFs from all these papers can be found in our Discord channel. Okay, and you can continue this discussion in the Discord channel also. Okay, I thank you so much to all presenters for this very interesting discussion. I lot a lot, I lot. I learned a lot also. I really enjoyed. Sorry, to be here, and the participants are send congrats, nice work, very interesting jobs. So all presenters, uh, my thank you very much, and I hope you all enjoy the rest of the conference. And the next activity is our panels. This is new this year, and I invited all of you to be there. And this session will be, the panels will be only in Portuguese. Okay, thank you very much. See you.